So welcome, Bruno. Welcome, Rigney. Welcome, Susanna. Um, Today is a very different day than we've had before because there is no quiz today. There's no homework due. There's only one thing on the horizon. My guess is that you all know what I'm talking about. Okay, in terms of this class at least. And then, of course, the horizon after this class is over. That's sundown. And so why don't I share my desktop? And again, I have a list of things to do, but not really, as you'll see. Okay, so notice the plan is very short in terms of items. And that is the first thing is any questions you might have about general stuff, and then prepare for the final. We don't have any new material to talk about. There's no homework due today. So you probably won't have questions about homework due today because there isn't any. There's no quiz today because, again, there's nothing due today. So today's a very different day than usual, and hopefully it'll go well for everyone. And hopefully others are figuring it out. A lot of people don't come until after the quiz, but the quiz isn't happening. So they'll figure it out eventually. So do you have any general questions first? Any general questions? Okay. All right, if there aren't any general questions, I think it's time to start talking about a final. And maybe I'll share the, that one, there we go, the syllabus, just to remind you, which you probably all know anyway, is that there is a final. And it is happening on Monday. And just a big note, it starts earlier than usual. Again, I'm using the times at which the college tells me to start, and they tell me to start at 8, and that's when I'm starting. And I think the reason for that is if we started later and we have a 2-hour final, then it can conflict with your next final on Monday. So I think that's why they start us earlier. But that's a big note, is that we're starting at 8. We're not, the final starts at 8. It doesn't start at 8:30. So big note. Also, it ends officially at 9:50. What I like to do is give you an extra 10 minutes in case you need something because it's technology issues. And so you'll have till 10 is the way it'll work. Okay, and note that the final is a big part of the grade. So out of the, not that many, there's what, 100, 2, 3, 4, 55, 50. Out of the 850 points, 200 are the final exam. So it's a pretty big part of your grade. So take it very seriously. And hopefully by now, you've been students long enough, you know how important finals are. Okay. When you get to the university, they tend to be even more important. They're usually 40 to 50% of the grade in the university for sophomore level stuff. So that's just a note. There's not much to say about the details, the kind of tech and stuff and rules. It's the same as the 2 exams. So you can use Proctorio, and you're going to have your cam open and your mic, and you'll just take the test. Okay, so that the rules are basically the same. You can't talk to anyone, and you can't communicate with anybody using you can't use any devices other than the computer that you're putting your test into. And that's just to open up the test. So the rules are pretty much the same. You're used to it, nothing new. Any questions at all about the procedure for the final exam? Okay, let me show you. That was kind of a joke, but it's, you know it anyway. It covers everything from, here we go. I just wanted to ask, does your exam policies for the first quarter apply to in the third quarter? Do well on exam? No, nothing is dropped on this one. There is no dropping of any exams on this one. Okay, we're already in the third quarter. Dropping is just doesn't happen at the university. I'm trying to get you ready for the university level, and that's how it is. So I'm trying to keep it constant that way. So yeah, so whatever your grade is on the final, you put that in and add that to whatever your course grade is, and that gives you your regular grade. Okay. So in terms of material, it covers everything from parametric equations to working with Taylor series. In other words, everything. Okay. There's nothing that isn't fair game. On the other hand, you're not going to have a problem for each of the different things we've talked about, because I'd have to give you 6 hours to take the test, and I can't do that. So I apologize if your favorite thing's not on the test, but I'm not telling you what is and what isn't on it. Okay, any questions at all on what it covers? Any questions on that? Okay, so hopefully you understand it's just a comprehensive final, nothing new about that. And in fact, I put in, it's like a half and half final, because this class really is 2 pieces. And so I just basically bulk together the second half of the class first and the first half of the class second for the exam. I figured that then you'll remember the most recent stuff a little bit easier. Okay, any questions? Okay, I think I should mention a little bit about exam 2. Maybe I'll go to it. Because that happened and I graded it. And there were a lot of different things that you guys did right and wrong. Okay. So in terms of the true false questions, I think that was the first one. Does that look right? Exam 2, Motley Proctor. Yeah, that's right. A lot of you struggled on the true falses. Okay, they weren't supposed to be trick questions, but they are questions that test to see if you understand the basic, the main material that we had. So if the summation n equals 0 to infinity, an is a series with positive an, and an plus 1 less than an for every n, and the limit is equal to 0, then the summation of an converges. So I figured I'd go over this because the final exam covers everything. So this is kind of a nice review of the last half of the class, and we haven't gone over it yet. Is that true or false, by the way?
False.
Yeah, and why is it false? What's the big example? It's the most important of all examples of all series.
HST.
Yeah, there's the summation of 1 over n. Summation of 1 over n is a series. We know it's always positive. You don't get negative for 1 over n. 1 over n plus 1 is definitely smaller than 1 over n. The limit as n goes to infinity of 1 over n is 0. So 1 over n does not converge. That's like the most famous one that doesn't converge, which we have used over and over and over again. Okay, you cannot use the divergence test to show a series converges. Some of you did that, and that's not right. So if the divergence test doesn't show it diverges, it just means that you have to use another test. It does not mean it converges. Any questions on this true false question? Any questions? Okay, again, a lot of you had troubles with these. I didn't mean it to be tricky. This is just, basically seeing if you understand the divergence theorem doesn't work for convergence. Okay, then we had If we have a power series or Maclaurin series for f of x, then the Maclaurin series for f prime of x is given by the summation n equals 0 to infinity of n plus 1, a sub n plus 1, x to the n. Okay, a lot of you had trouble with this. So the key on this one is to realize that f prime is the sum from n equals 1 to infinity of n an x to the n minus 1. And then you got to compare it. Okay. And again, proving it is one way. I think the easier way to really see it is just write down what this is. And that is, again, if n equals 1, you get a1 times 1, just a1, plus, and then if n equals 2, you get 2, a2, x, plus, and if n equals 3, you get 3 times a3, x squared, plus dot, dot, dot. Any questions so far? Okay, so that's what you get for the n for f prime. Now let's see what you get for this guy. Well, let's let n equals 0. What do you get for n equals 0? What does this become?
1.
It's right, 1 times, keep going. So if n is 0, we get 0 plus 1 is 1. And then times a sub 1 times 1, which is just a sub 1. Plus. Okay, then if n equals 1, 1 plus 1 is 2 times a sub 2. And then x squared. Sorry, if n is 1 times x, there we go. And then if n equals 2, you get 3. 2 plus 1 is 3. A sub 3 x to the 2 plus dot, dot, dot. What do you notice between the two?
Arithmetic, not geometric, because it's consistently adding.
No, but when you compare this one with this one, what do you notice? Yeah, they're identical. Okay, so it is true because this sum really is the same as the derivative. Okay, wasn't meant to be a trick question. If you just plug in, it works. The other thing you could do is you could let u equal n plus 1. And when you do that, let's write this down. So again, the way I've done it isn't quite a proof, but it's definitely seen that it's working. So a proof is you let u equal n plus 1. And then when n equals 0, then that means u is equal to 1. Any questions on that? And then we just substitute. We get the sum from, so n equals 0, u is 1, so u equals 1 to infinity. And then the next thing we do, we say n plus 1 is u, and that's a sub u, x to the, and n is u minus 1. And then this is really important. The letter doesn't matter. So they call that a dummy variable. So whether you call it u or n, it means the same thing. And that is the f prime. So that's the full proof. So this is true. So a lot of you had trouble with these true falses. Wasn't meant to be a trick question. You just had to look at this and realize what the sum does and then see it as a derivative. But most of you had trouble with question 3. Any questions on this? By the way, the reason I'm going through this in detail is that this is a kind of like a summary in a way of the last half of the class. So by going through this, I'm going through the last half of the class. We still have to talk about the first half, but we do have, a long time. There's no quiz today, so we have plenty more time. Okay, but I'm a little worried that most people aren't here yet. Hopefully they realize there's no quiz, so we're going over stuff. I did a little curve. Okay, let's look at question 4. So determine the radius and interval of convergence of the following series. Be sure to state each test you're using. Okay. By the way, that's a hint. It's not just one test. There's gonna be multiple tests to do. What's the first test we almost always use when you're talking about radius and interval of convergence? How do we start? Kind of gave you a step-by-step when we went over this a week or 2 ago. Yeah, ratio test. So let's use the ratio test. Okay, and the ratio test, it says that we're going to take a limit of the absolute value, and then you plug in n plus 1 for n, so we get x plus 3 to the n plus 1 divided by 5 to the n plus 1, and then times n plus 1 minus n plus 1 to the 1/3. There we go. And then times, let's see. There we go. And then times, and then you're going to take the reciprocal of an, and that's 5 to the n times n minus n to the 1/3, and then divided by x plus 3 to the n. And the absolute value. And now it's time to simplify. So to simplify, what you're going to do is you're going to have an x plus 3 to the n plus 1 divided by x plus 3 to the n. And hopefully you all know that's x plus 3. Okay, then we have an over. And then we're going to have a 5 to the n plus 1 divided by 5 to the n, and that's just 5. So stop me if there's anything you don't understand. And then times, now let's do the other piece, n plus 1 minus n plus 1 to the 1/3 divided by n minus n to the 1/3. Okay, how did you get rid of the ns coupled with 5? Okay, so we have 5 to the n plus 1 here. And we have a 5 to the n here. And the power rule for exponents says that when you divide, so we have a 5 to the n is on top, the 5 to the n plus 1 is on the bottom. And when you divide, you subtract the exponents. So n minus n plus 1 is -1. So 5 to the -1 is 1/5. Does that make sense? So that's simple rules of exponents. But again, it's real messy. The whole thing is messy. Okay. All right. And the nice thing is the absolute value of x plus 3. And I'll put the 5 first. It looks a little prettier. 5x plus 3. I could pull that outside the limit because it doesn't have an n in it. Times the limit. And there's a lot of ways of approaching this guy. Okay. Probably the easiest is to use L'Hopital's rule. Notice you get infinity. As n goes to infinity, you get infinity over infinity. So if we use L'Hopital's rule, the n plus 1 becomes a 1. And then the n plus 1 to the 1/3 becomes a 1/3 n plus 1 to the negative 2/3. And then we're dividing by 1 minus, again, L'Hopital's rule, 1 minus. And then we have 1/3 n to the negative 1/3, 2/3, negative 2/3. Any questions on the L'Hopital's rule? Then I can use L'Hopital's rule again. And it starts the same. And then the nice thing is the 1 goes away. And you'll notice you have a 1/3 times negative 2/3 on the top. You have a 1/3 times a negative 2/3 on the bottom. They go away. All the negatives go away. And you end up just getting n plus 1 to the negative 5/3. Divided by n to the negative 5/3. Okay. And the nice thing about this is we can start the same way. You can pull the 5/3 out, and we get n plus 1 over n. All to the negative 5/3. And now that limit is just 1. So we get 5 times x minus 3, x plus 3. Now we're using the ratio test. So what do I set that to? Yeah, less than 1. So that means the absolute value of x plus 3 is less than 1/5. Divide by 5. And what does that tell us? Oh, you know what? The 5 was on the bottom. I lost it somewhere. Yep. I knew there was something wrong. All those times 5 should be over 5s. That's why I always look at the problem and make sure I double check. And then multiply by 5. And then what we get is the endpoints are, well, if you plug in negative 8, we get a 5. And if we plug in 2, you get a 5. Okay, that's not the interval of convergence. Okay, that gets us there, but we're not there yet. Now what do we have to do? Yeah, now we need to plug in, and we're going to have to use some more tests, and never the ratio test again, because the ratio test will fail at -8 and 2 because you get 1. That was the whole point. So now let's look at it. X equals, how about -8 first? And an x equals -8, you get the sum. And -8 plus 3 is -5. -5 to the n over 5 to the n is -1 to the n. So it's sum of -1 to the n over n minus n to the 1/3. So now we want to find out if that converges. What test do we use to see if that converges? Looking for kind of a 3-letter abbreviation. Yeah, we're going to use the alternating series test. So AST, note that the limit of 1 over n minus n to the 1/3 is equal to 0 because n is more dominant than n to the 1/3. So it converges at x equals 8 by the alternating series test. Okay, then we got to do x equals 2. So if you plug in 2 now, 2 plus 3 is 5, 5 to the n, 5 to the n over 5 to the n is just 1. So you just get 1 over n minus n to the 1/3. And what test should I use to see if that converges or diverges? Okay, P series, this is not a P series. P series can't have a plus or minus inside. So we can't use a P series test. Because it's not a P series. So what can we use? I don't see y'all jumping in. Okay, the idea is we can use the direct comparison test. So first thing is the sum of 1 over n diverges by the HST, harmonic series test. And 1 over n is greater than 1 over n minus n to the 1/3. Right? Because notice that n minus n to the 1/3 itself is smaller than n because you're subtracting something. So that means that reciprocal of that will be bigger. Okay. Wait, sorry, to have the wrong way around. Less than. There we go. So by the direct comparison test, and the harmonic series test for 1 over n, the series diverges. So finally, the conclusion is that the interval of convergence includes -8. So square bracket -8, comma 2 does not include 2. is the interval of convergence. Any questions on that question? Again, I figured I should go through these because it's almost a review for the last half of the second half of the class. So it's a little this, little that. Okay, question 5. Find the Maclaurin series for x to the 5th sine of x squared. All right. Here's what you don't want to do. Boy, some of you were just wanted to torture yourselves. The last thing you want to do is make a table and find derivatives until you see a pattern. Boy, that'll be awful. You'll be doing product rules forever. Instead, what do we use? It's a pretty easy problem if you know what to do. It's not tricky or anything, but you have to know what to do. Yeah, we do the Maclaurin series for the sine of x. That was one of the big ones I said you should know. So we still have the x to the 5th. It doesn't go away. Okay. And by the way, if you didn't remember the Maclaurin series for sine of x, you can find the Maclaurin series. It's not that hard. But even better is to know it. Again, there's only a few series you need to know. You need to know sine of x, cosine of x, e to the x. Okay, and I guess the binomial. That's it. It's not like you have to know 100 of them. There's only 3, and the binomial. There's 4. Okay, so x to the 5th. And then sine of x squared. If you remember, the way I like to remember it is I know that the sine of x is an odd function. Okay, it's an odd function. That means I just got to have 2n plus 1s instead of 2n's. So we're going to have a -1. I guess I should write sum. And then -1 to the 2n plus 1. And then divided by 2n plus 1 factorial. Now, normally it would be x to the n. I'm sorry, -1 to the, sorry, not 2n plus 1. That was a mistake. I always have to double check. -1 to the n times 2n plus 1 factorial. Normally, we would have an x to the 2n plus 1. But what are we going to have now for this problem? Okay, n plus 2, not quite. Let's look at it. So what we're going to do is where you see an x, you're going to put an x squared. It's just a substitution to the 2n plus 1. And that is equal to the sum of -1 to the n over 2n plus 1 factorial x to the, and now if you have x squared to the 2n plus 1, that's to the 4n plus 2, and then add 5 is 4n plus 7. And there's our answer. Any questions at all on this one? Okay, let's go to the next one. Okay, use geometric series to find the Maclaurin series for this guy. Okay, so for part A, what do we have to do first? What's in the way? So why can't we just jump into the geometric series without doing anything? There's one thing we have to do before to make it a geometric series. Yeah. Divide all terms by 4, or really what we're doing is we're factoring out of 1/4. So we're going to have 1/4 times x to the 1.7 over, okay, 1 plus 1 over 4 x to the 3.5. And now we're ready. Okay, now we're ready for the geometric series. And we can say equals the sum of, and now what we have is the geometric series says, and actually let's rewrite this plus just to show you what's going on, minus a minus, because geometric series is supposed to have a minus. So we're gonna have a sum, and now it's going to be 1/4 x to the 1/7. And then it's going to be times the r to the n. And I'm going to put this into pieces. The negative can go by itself, and I can make that -1 to the n. And then times 1/4 to the n. And then times x to the 3.5 to the n, or 3.5 n. And then because of part B, we're going to have to integrate. Let's put the x's together. Otherwise, it's too hard to integrate this guy. So this is equal to the sum of, and I'm even going to do the 1/4 times 1/4 to the n is 1/4 to the n plus 1. Just makes it a little prettier. And then times x to the, and actually, let me put the -1 to the n. Times x to the, and we have a 3.5 n plus 1/7. Any questions on that so far? That's part A. Part B is to integrate. Okay, and by the way, if you don't simplify part A, you're not going to be able to integrate. So that's why, I really went through all the details of simplifying. Otherwise, you won't be able to do it. So now for part B, we just integrate term by term. The first part doesn't change at all. In fact, very little changes. The power goes up by 1. So 1/7 becomes 8/7. And then you divide by that up 1 power. And then finally plus c. Any questions on this question? Okay, getting there. Okay, so the next is determine whether it converges absolutely, conditionally, or diverges. All right, so this one, it's always good to kind of guess what it's going to do first. Let's look at part A. Do you think it converges or diverges? Think it converges absolutely? Do you think it conditionally, or do you think it diverges? What's your guess? It's always what you want to do first is guess. And if you practice a lot, you'll guess them right just about every time. Okay, you think it converges absolutely. Okay, well, let's see if that's true. So part A, what we need to do is we need to look at the sum of 1 over n plus 2. If you think it converges absolutely, that better converge. But if you look at the dominant piece of that, that's a dominant piece is 1 over n. Do you see that? So let's just do this because we're going to need it anyway later. And that is, let's use the LCT, the limit comparison test, with 1 over n, which diverges by the harmonic series test. And then we know that the limit of 1 over n plus 2 times n is equal, using L'Hopital's rule, the limit of 1 over 1 equals 1. So by the limit comparison test, it diverges. So one thing for sure, it doesn't converge absolutely. Okay, because if it converged absolutely, we took an absolute value, you should get convergence, not divergence. But maybe it converges conditionally. So to do that, let's use the alternating series test. Well, the limit of 1 over n plus 2 is equal to 0. So by the alternating series test, it converges conditionally. Any questions on A? Because we showed that the absolute value diverges, but the series without the absolute value converges. So that's conditional. Now for part B, there's actually a couple ways of doing part B. And I'm going to let you say to do part B, because part B is a bit messy. What do you want to try for part B? Do you have to show error? Oh yeah, we got to show error. So we're not quite on part B yet. Okay, and the error is pretty easy actually, because we want to show that the error, if the error is less than 0.001, then what is n? And the theorem says just go to the next term in absolute value. So 1 over n plus 3 needs to be less than 0.001. Take a reciprocal, and you get n plus 3. Reciprocals switch the inequality, so we get greater than. 1 over 0.001 is 1,000. I know one of you said 100. So n needs to be greater than 997. So n equals 998 is the smallest n to use. Yeah, thanks for reminding me. I got to grab that one too. Okay, now we go to part B. So what test would you like to use, or what would you like to do for part B? There's two that were pretty much the same in terms of difficulty. What's your request? For part B? I don't see y'all jumping in. Maybe I'll remind you on a couple things. If you see a factorials, what's often the thing you want to use? What's the kind of classic test to use with factorials? Yeah, ratio test. Okay, so let's use a ratio test. So if we use a ratio test, we're going to take the limit. And then where we see an n, we're going to put an n plus 1. We'll also take an absolute value. So we have 2n plus 2 factorial over n plus 1 factorial 2 to the n plus 1 times the reciprocal of the original. So that's going to be n factorial 2 to the n over 2n factorial. Okay, it might help to put everything together where it belongs. So I'm going to write limit, and I'm going to have a 2n plus 2. Oh, it shouldn't be the 1. It should be factorial. Sorry about that. So we're going to have a 2n plus 2 factorial over 2n factorial. And then we're going to have a 2, we're going to have a 2, sorry, we're going to have an n factorial over n plus 1 factorial. And then we're going to have a 2 to the n over 2 to the n plus 1. Any questions so far? Okay, now a lot of people have trouble with this. 2n plus 2 factorial over 2n factorial. So 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n times 2n minus 1, etc. 2n factorial is 2n times 2n minus 1, etc. So you'll notice that the 2n plus 2 and 2n plus 1 are the only ones that don't cancel. So I get a 2n plus 2 times 2n plus 1. Any questions on that first piece? A lot of you had trouble with that. Okay, and then times. N factorial over n plus 1 factorial is 1 over n plus 1. Any questions on that piece? Times 2 to the n over 2 to the n plus 1 is a half. Still need a limit. And now you look at this and you'll notice that the numerator has an n squared and the denominator only has an n. Okay, and in fact, you can even do better. I could take this 2n plus 2, and I could write that as a 2 times n plus 1. Just factor the 2 out. Then I won't even have to use L'Hopital's rule. And then the n plus 1s cancel. And I get the limit. And all the 2's cancel also. The 2n plus 1s cancel. I get the limit of 2n plus 1. And that's infinity. So now what do we say? So what does the ratio test tell us if you take a limit and you end up with infinity? Positive infinity. So what's the ratio test tell us? Yeah, diverges. Any questions on that? Okay. Again, I'm going through all of these because it's half the test is going to be on this stuff. I mean, it's not going to be exactly these problems, but same idea stuff. Okay, use the definition to find the third degree Taylor polynomial centered at x equals 2 to approximate the function. Okay, so use the definition means we need a table. Any questions on that? Maybe let's pop in a table. We have an n. We're going to have an f super n of x. And we're going to have an f super n of 2. Okay, so then we're going to have 0, 1, 2. Let's see, we want third degree. And 3, so I guess we don't need this guy. There we go. Okay, we have ln of 3n plus 1, 3x plus 1. Plug in 0, you get what? Nice and easy. What's ln of 1? Oh, sorry, not plugging in 0, plugging in 2 is what I meant. And you get ln of 7. Okay, then we take a derivative. That's going to be 3 over 3x plus 1. We plug in 2, and we get 3/7. Any questions on that? Then we take a next derivative, and we get 9 over 3x plus 1 squared times -1. So it's -9 over 3x plus 1 squared, which is -9 over 7 squared, which is 49. Then we take another derivative, and now we get a negative, so that's positive. 9 times 2 times 3. So that's 9 times 6 is 54 over 3x plus 1 cubed. And now plug in 2, and we get 54 over 7 cubed. So 7 cubed, well, 7 squared is 49. 50 times 7 is 350 minus 7 is 343. Any questions on the table? Okay, now we want the Taylor polynomial. So what we get is the first term is just ln of 7. And then we're going to have plus. And then the second will be 3/7 times x minus 2, because we're centered at 2. Let's write it like this. Looks better. Any questions so far? Minus, and it's a minus because there's a minus in the f double prime. 9 over 49 times 2 factorial, which is just 2, times x minus 2 squared, almost there, and then plus 54 over 343 times 3 factorial, which is 6, and then times x minus 2 cubed. Any questions on part A? Okay, for part B, we're going to use a remainder estimate. And if you remember, for the remainder estimate, you need to take the next term. So we take the next term. So we need one more derivative. And the next derivative is, notice that f4 of x is equal to, it's let's just write it this way, 54 times 3 times -3. Negatives don't matter because we're taking an absolute value anyway. Okay, times -3, and then divided by 3x plus 1 to the 4th. Okay, and the theorem says what we're going to, and then we got to do some, so the theorem says we're going to use the biggest value this could be in absolute values. So the negative goes away. And then notice that the x is the denominator. So that means 2. When x is 2, it'll be as large as possible. So when x is 2, that's a 7 to the 4th. So this is going to be less than or equal to 54 times 3. I'm going to do 3 times -3, or 3 times 3 is 9, times 9 over, and 3 times 2 plus 1 is 7 to the 4th. So our remainder is going to be less than this number, 54 times 9 times 7 over 7 to the 4th, divided by 4 factorial. I'll just leave it as 4 factorial. And then we're talking about a 5 minus 2 to the 4th. And my rule in the test is if all that's left is arithmetic, you can just leave it. Any questions at all on question 8? Okay, then let's do question 9 quickly. Use the appropriate substitution to write down the Maclaurin series for the given binomial. Okay, so the idea here is 2x is what we're going to substitute in. Our r is 1/3, and it's very straightforward. It's just using the formula. So what's the first term for the formula? Always? Nice and easy. 1. Okay, plus. And then we're going to have the derivative, or we're going to have 1/3. In fact, I'm going to write 1/3 divided by, actually, I didn't have to write that. It's divided by 1 factorial. And then what's next? So what do you multiply that by? Well, Armand, that's for the next term, but I still have a little bit more. Yeah, but it's not going to be x. You got to be careful because this is an x. It's 2x. So it's times 2x. Any questions on that? Because we got to substitute in the 2x where we see, because it's to the right of the plus sign. Now we can go to the next term. You guys all want to jump to the next term, but we weren't ready yet. Now we're ready. So now we're going to say 1/3 times, and again, 1/3 minus 1 is -2/3. And then over 2 factorial. And then it's times 2x squared. Any questions on that so far? We're almost there. Let's do one more and then we'll do dot, dot, dot. Plus 1/3 times -2/3, 2/3. Over 3 factorial. And then times 2x cubed. And then plus dot, 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 plus Okay, and then we just kind of show the way it goes. We're going to have 1 over 3 times negative 2 over 3 times dot, dot, dot. And then we're going to have a 1 over 3 minus n over n factorial times 2x to the n. And then plus dot, dot, dot. Any questions at all on using the substitution for the Maclaurin series for this using the binomial? Okay, so now do the last one. Determine if the series converge or diverge. Make sure you state the test you're using. All right, so we have a summation n equals 0 to infinity, n squared plus 1 over n cubed minus 2.5. So for this one, what test? For part A? What test do you think is going to work for this one? Yeah, DCT with what? So what are we comparing with? Yeah, with the summation 1 over n, which diverges by the harmonic series test. And then since, so you could do DCT, but I think we need to do LCT. I don't think it's that obvious about the inequality. Proving that's pretty tough. So I think we need to do a limit comparison test, which isn't that hard, with the harmonic series. So then we're going to take the limit of n squared plus 1 over n cubed minus 2.5. And then times n. And what we get is the limit of n cubed plus n over n cubed minus 2.5. I can use L'Hopital's rule because you get infinity over infinity. And that is 3n squared over plus 1 over 3n squared. I can use L'Hopital's rule again, and I get 6n over 6n, which equals 1. So by the limit comparison test, the series diverges. Any questions on that? All right, how about part B? What test for part B? Yeah, you know what happened? I apologize for this. I didn't mean integral test. I actually originally meant integral test, but I had a typo in the problem. The problem still works, but you just can't use the integral test. So sorry, I noticed that afterwards it was too late. Yeah. So it's going to use the divergence test. Yeah, so originally that was supposed to say 6n squared, but it didn't. So you can still do it with the divergence test. I didn't feel so bad because it's still doable problem, but it wasn't quite what I meant it to be. So we're just take the limit of what we have, and that's e to the n plus 6n over e to the n plus 2n cubed plus 7. And I can use L'Hopital's rule. L'Hopital's rule is very valuable when talking limits. So we get e to the n plus 6 over e to the n plus 6n squared equals, do it again, limit of e to the n over e to the n plus 12n I could use L'Hopital's rule a couple more times, but I think it might be easier to just divide by e to the n on top and bottom. So you get limit is 1 over 1 plus 12n over e to the n. You know, I think I need one more L'Hopital's rule to make this work nicer. So limit of e to the n over e to the n plus 12. And I might as well just use L'Hopital's rule at that point. And that's the limit of e to the n over e to the n. And that's 1. So by the direct comparison test, the limit comparison test, the series diverges. Yeah, that was actually meant to be something, but there was a typo, but it still works. I don't feel guilty because it still works. It's just I wasn't able to test it on an integral test. Any questions on this? Okay, so that's the exam. I figured I should go through this because this is a nice review of the second half of the class. There any questions about this exam? Any questions? Okay, so now let's go back and kind of dust off some old memories. Very important. I think I just, I'll just hit submit. Yeah. Okay, so I'm going to dust off some old memories and let's go back to the syllabus. So that was kind of a review of everything we did in the last half of the class by looking at that exam. But what I want to do is remind you about a lot of things that happened a long time ago that are definitely fair game for this exam. So then there's the first half of the class. And that's parametric equations, polar equations, taking derivatives of them, vectors, dot product, cross product. Then there were all the geometry stuff, lines and planes and quadrics. There's cylindrical coordinates and there's spherical coordinates, functions of more than one variable. And then there was a calculus of that, limits, continuity, partial derivatives, tangent planes, gradients, and Lagrange multipliers. Okay, that's, and max min, which is also Lagrange multipliers and gradients. So that is a very fast recap of everything we did in the first half of the class. And what I thought I would do, unlike what we just did, which is going over the exam, which was a nice recap of everything that happened, you know, just about in the last half of class, maybe I'll take a suggestion. What kind of thing would you like to review? Because we don't have enough time to review every single topic. And I want to let you know, I can't test you on every single topic because it would be way too long. Okay. If I gave you a test problem on everything we did in class, none of you would finish. Do y'all agree? It would be a complete disaster. Okay. So cross products. Okay. So I want to remind you a few things about cross products. First thing is the how to do them. Yeah, you give. I think I give. I couldn't finish the whole thing if it was every problem, every type. Yeah. So just let you know that if your favorite things on the test, I apologize that you're not seeing it. I don't know what your favorite things are though, because I can't put everything up there. Okay, but I can look at a cross product. So a couple things. One is how do you do the cross product? And that I like to use the matrix. Find the determinant of I, J, K, U, and V. And that gives you cross product. But then the other thing is the geometry of the cross product. So for the geometry of the cross product, do you remember if you take a U and you cross it with a V, what do you know about the cross product geometrically? Do you remember? It's been a while, but it's very important. Yeah, the cross product is always normal or orthogonal to both of the two other vectors. Any questions on that? So maybe I'll just say find a vector orthogonal to, let me just make up a couple vectors. Three, comma, 2, comma, -1. And how about 1, comma, -2, comma, 4? Just throw in some. Hopefully those aren't orthogonal to each other or not. Yeah, that's fine. So do you remember how to do that? So here's a hint. What do you think we need to do to find a vector orthogonal to both of these? Should be obvious since you just asked about it. Yeah, cross product. Okay. So what we need to do is we need to do a cross product. So we can have I, J, K, and then 3, 2, -1. And then 1, -2, 4. Any questions on that so far? And then if you remember, for the I component, you get rid of the I row and column. And then we take the determinant, or 2 times 4, minus -1 times 2. Times -2. I. And then we do minus. And then for the J, we take the Jth row and column out, and you get 3 times 4. Let's try this 3 times 4. And then minus -1 times 1. J. And we take the K component, you get rid of its column and row, and you get 3 times -2. Minus 2 times 1. Okay. And then you do baby arithmetic. So 2 times 4 is 8. 8 minus 2 is 6. 6i. And then we have 3 times 4 is 12. 12 minus a minus 1 is 13. So you get minus 13j. And then we're going to have a 3 times -2 is -6, minus 2 is -8. Okay. How do you check your work, by the way, on this one? What's the easiest way of checking your work? Make sure you got it right. Because it's important to know how to do this and to know the math, the calculus. I'll even write it in other vector form. You know how to check your work? Okay, so we wanted to find a vector orthogonal to both of these. How do I know that these two are orthogonal? How do I know that 6, -13, -8 is orthogonal to 3, 2, -1? Yeah, we take the dot product and make sure you get 0. And again, you could probably do that in 5 seconds, so it's worth it. And you will get 0, by the way, if you work this out. Any questions on that? Okay, so does the limit exist? So let's take a look. That's the next request. So determine whether the limit exists. And now I got to actually use an equation to make it look pretty. Okay, so limit as x comma y goes to 0, 0. I'll also make it easy. Of x squared actually, let's go x squared is fine, plus xy plus 4y squared over x squared plus y squared to the how about 7/2? Something like that. All right, so how do you decide? I know it's been a while, but it's time to review. Okay, good. The first thing you do is you make a guess. What's your guess? Okay, so if you think it doesn't exist, then what do you do? Yeah, show 2 ways. And what do you want to show? Or 2 paths is a better thing than ways, actually. Yeah, so it's not 2 ways, it's 2 paths. That's the first thing. Okay, so we find a path that goes to the origin. And I like to choose the easiest ones. So how about the positive x-axis? So let y equal 0 and x greater than 0. Any questions on that? Okay, and actually let me copy and paste is the easiest. So now if y is 0, then we're not talking about x, y going to 0, 0. We're just going to have x going to 0. And then y equals 0. So if y equals 0, anything with a y in it goes away. Any questions on that? What do you get? This might not have been the best example. Again, making it off the top of my head is hard. This might be a little too easy, actually. But it can't hurt. So I'll do some more. What do you get? What is x squared to the 7 halves? Start on the bottom there. Yeah, it's not 7, but it's x to the 7th. That's probably what you meant, though. So we get x to the 7th on the bottom. But that is just 1 over x to the 5th. And if x goes to 0, what do you get? Yeah, d and e. So the limit does not exist. Any questions? That was a bit easy because as soon as you got one path, it was over. Let me do another one or two. So this time I'll think a little deeper.
Wait, so if it does not exist, you don't even have to show the other way?
Once a path doesn't work, limit doesn't exist.
Okay.
Yeah. So that was kind of nice and easy. So now we'll do one a little harder. So same thing, term where the limit exists. And in fact, let's just do this and adjust. Whoops. Let's try that one. I didn't change much. I just turned the 7 into a 1. What do we do? What's your thinking? Okay, if you think it exists, what do you have to do? Right, now we need to use polar. Okay, or plow if you want. Polar. So you go to polar coordinates. So when you go to polar coordinates, let's see what we get. Instead of x, y going to 0, 0, now we're going to have r going to 0. Whoops. Huh. Oh, it didn't like that. So let's start again. So what we get is x squared is going to be r squared times, now x is the r cosine theta. So cosine squared of theta. And then plus, then we're going to have r squared times cosine theta sine theta. And then plus 4 r squared times, and then y squared is going to be sine squared theta, r squared sine squared theta. What's x squared plus y squared to the 1/2? So what's x squared plus y squared to the 1/2? Nice and simple. That's a hint. So what is x squared plus y squared to the 1/2? What is this denominator? Yeah, that's just r. And the good news is this simplifies nicely. I can cancel out the r's. I get a 1 on the bottom. And the squareds go away. And now when I plug in r, what do I get? Yeah, 0. So the limit is 0. Any questions on that? Any questions so far? I'm going to play around with this one again. What if we don't have the 7/2 at all here? Now what happens? What do we need to do? Any thoughts? So let's see if you can guess. Do you think the limit exists or not? What you're thinking? Okay, if you think it exists, then we should do the same thing that we just did. Okay, and if you do that, I can copy and paste basically. But that r becomes an r squared. And then I cancel the r squareds. And when I do that, I get the limit of r going to 0. And the r squareds are gone. We get cosine squared of theta. plus cosine of theta sine of theta and then plus 4 sine squared of theta get that print, see there? And that's a mess. Do y'all agree? Yeah, so that didn't work. Okay, you want to adjust your guess on what the limit exists? Yeah, let's try does not exist. So now let's let y equals 0. So we're going to do the positive x-axis, x greater than 0. And when you do that, we're going to have a limit. And now it's going to be y goes to 0. Oh, sorry, x goes to 0. And now let's work this out. We get a numerator. If y is 0, you just get x squared. And if y is 0 here, you get x squared. What's that limit? Nice and easy. Yeah, it's 1. Okay, what's another path we might want to try instead of y equals 0, x greater than 0, instead of the positive x-axis? Go into 0, or the origin. So that was one path. What's another path that we can try? It's the next easiest path. Yeah, let's try the positive y-axis and go down towards the origin. So same idea. In fact, I think I can copy and paste and adjust. So let's let x equal 0. Let's let y be greater than 0. And then we're going to let the limit as y goes to 0. Now we're going to plug in x equals 0, and you get a 4y squared over y squared. What is that limit? That's 4. What does that tell us? Yeah. The limit does not exist. Any questions at all on that? Did that help? Is that kind of what you wanted to see? These kind of examples? Okay. And not every example looks exactly like that with different, with the denominator, different powers, but I figured that you get to see every type or most of the types. Okay. You want to look at Lagrange multipliers? Okay. So question is, find the critical points. Let's go extrema of the function f of xy. I'll let you choose 2 variables or 3 variables. 3 variables, x, y, z. Equals, how about x squared plus yz subject to the constraints x minus y squared plus xz equals 1, and x, y plus, let's go here, plus x plus z squared equals 2. I'm making this up, so it may not be nice, by the way. The one big difference between the exam and practice problems is practice problems I'm making up in my head, and I have no idea if they're going to come out nice. Exam problems I make up in my head. If it doesn't come out nice, I adjust until it comes out nice. So just a warning. I have no idea with this one, but this is a type of problem to do. Okay. So what do we do? So what's the plan? Okay, you grunge it up. I like that. Okay, you grunge it up. Okay, yeah, because we use Lagrange multipliers, but what does it mean we need to find? What's our first step? What do we have to find for these three things? Remember? Yeah, we need to find the gradient. So grad of f equals. So hopefully you remember how to find the gradient. What's the gradient of this function? What's the gradient of f? It's pretty simple. I didn't give you some evil gradient. Yeah, it's 2x comma z comma y. And that is equal to a times the gradient of g. And the gradient of g is going to be 1 plus z comma 2y comma x. And then you go plus b times the gradient of the second constraint, which is, so that will be y plus, or let's go 1 plus y, comma x, comma 2z, like that. Let me stop. Any questions on that? Okay, what do we do with that equation that we have here? We solve for a and b, but more importantly, we write it as 3 different equations. So we write it as 3 different equations. Sometimes you solve for a and b, sometimes you don't, but you always write it as 3 equations. And then we have the last 2 also. So we have 2x is equal, let's write in equations. 2x is equal to 1 plus za, or a times 1 plus z, and then plus b times 1 plus y. And then the second equation is z equals, we have 2ay plus bx. And then the third equation is y equals, and we have ax plus 2bz. Okay, and then the last two equations are the constraints. So I can just put them in. Any questions on that? Okay, now I don't have time to solve this whole thing. I think it can be it's a little bit messy. What I would probably do on this one is I would probably solve for the easiest ones. So I'm looking at either, I'd probably solve for y and get rid of the y's, because y is ax plus 2bz. So everywhere I see a y in the other four equations, I plug in ax plus 2bz and get rid of that one. And then do more horrible math. Okay, it's a lot of algebra. It's a lot of algebra. Okay, at this point, but the rest is just algebra, and then you find out x, y, and z, plug in. Okay, and again, I made this top of my head, so this is probably messier than I would give you on a regular, final problem. But it's the same idea, just not as messy for the regular one. All right, we're running out of time. We're about out of time, so I want to mention I will be in office hours right after class, as always. And I guess for you guys, that'll be the last office hours. Okay, I mean, you can come to my office hours next week, but the final's over. What's the point? You're welcome to. I'll be on at least Monday, Tuesday, Wednesday. After that, I have no students left, so there's no reason to have office hours. But I will be around in my office hours. I will also be checking my email pretty much. I usually get out a little bit on the weekends, do some hiking or something. But other than that, I definitely will be checking each day. So if you come up with any questions about anything, pop me an email. Also, there's tutors, and tutors can help. And I know Braulio has a lot of hours on Sunday, and I'm sure there's some others too. I know about him because he's my embedded tutor for stats, but he also took the full two years of calculus and can help you out if you're stuck on anything. But definitely, we're here to help out. I grade differently for the final. I don't put in comments because the comments aren't going to help you in terms of your grade, because by the time you read the comments, your grade is already like in at the college. So I don't put in comments. I just give you a total grade, and that's all that matters. So just a warning that you're not going to see comments. That way I can get it done fast. But I will probably, there's a chance I'll have it graded on Monday. If not, I'll have it graded on Tuesday, and the grades will be in. So don't forget, Monday morning at 8 is your final exam. That's the most important thing. And between now and then, I can answer some questions. Obviously, I have office hours now, but I also will be around looking at email. And I want to also mention, although there's not too many of you here, but if you see me around, I want to remind you, it's a little weird, but I always have my camera on. You rarely have your camera on. So I may not recognize you if you see me in the market. Make sure you tell me who you are. Say your name and what class you're from. And then I'll say, oh yeah, now I remember you, because I don't see you guys. So it's just a weird situation. But just let you know, I might see you around town or something. I might see you. I'm on sabbatical next quarter, but then I'm coming back in the winter. So I'll see you on campus then. So just let you know, I'll be around, but make sure you tell me who you are, because I may not recognize your face because all I see is a name on the screen. So hopefully you understand. It's just weird. Things will be better. And by the way, remember that model that I made on COVID using our calculus? Do you remember that about a month and a half ago? Yeah, if you look at it, we're there. It's like almost perfect. So, and again, it's not because I'm so a genius. All I did was use your basic calculus. And so it really matters. In fact, I just saw in the news yesterday, they're not even going to state the El Dorado County daily positive cases because there's so few. They're going to do it by week now because it really has dropped exponentially, just like the model showed. So it's kind of cool. That's the good news, is that unless some disaster happens, we're back. That's the good news. Okay, and within a month or two, as we mentioned, it'll be rare to even hear anything around here with a positive case. So that's great. Okay, so math actually works. I like that. So anyhow, I'm going to stop my share. And I'm going to stop the recording.